13.4 Partial Derivatives Part 1. Suppose you are hiking on a surface described by a function z equals f of xy, where x gives your east-west direction, y gives your north-south direction, and z gives your elevation. Assume you are standing at the pass or the saddle point. If you walk east, that is the positive x direction, the elevation increases. If you were to walk north, that's the positive y direction, the elevation decreases. Suppose that you travel strictly east with no movement in the north-south direction. Then any change in elevation is due to the change of x. And the rate of change of elevation when y is fixed and x is moving is called the partial of f with respect to x. Similarly, the rate of change of elevation when x is fixed and y is moving is called the partial of f with respect to y. Here are your formal definitions. And now let's move on to an example. Suppose this surface is described by the function f equals x squared minus y squared plus 4. Then the saddle point has a height of 4. I'd like to compute the partial of f with respect to x. To do that, I need to keep in mind that y is fixed. It is a constant value. So I need to treat it as a constant. This is not implicit differentiation because y is independent of x. I'm going to take the derivative of each of these three terms with respect to x. Y is held constant. And so the derivative of y squared with respect to x is 0 because y is not a function of x and y is being held constant. This is what I get, 2x. Now we evaluate this at a point behind you, 2, negative 4. It's behind where you're standing. You can't see it. It's on the other side of the pass. If you were to move east from the south side of the pass at this point, 2, negative 4, you would gain in elevation at a rate of 4 units up for every 1 unit east. Now let's find the partial with respect to y and evaluate it at 2, negative 4. For the partial with respect to y, I get negative 2y, and evaluated at 2, negative 4, I get 8. Let's do a different example. We have a new function. I'd like you to turn off the video and compute the partial of f with respect to x, partial of f with respect to y. Did you remember the chain rule? So this is my final answer for the partial of f with respect to x. And I also give you at the bottom the partial of f with respect to y. A new example. Compute the partial with respect to x. You're going to need the product rule and the chain rule. So here's the product rule, and now the chain rule, and this is my final answer. Let's do the same function, but compute the partial with respect to y. Again, turn off the video and turn it back on when you're ready. Notice that y only appears once. I pull the coefficient x squared out. X is being held fixed. In taking the derivative, I have to remember the chain rule. I take the derivative of xy with respect to y, and I simplify. There is more on this subject in part 2.